All right, guys, how we doing over here? All right, let's see if I can make this slightly bigger. We'll need the space. All right, so it says find the average rate of change for the given intervals. So we have 3 tables here. Just kind of make it clear. I'm going to kind of separate them so we can see where we do our work for each one. That should be enough space. All right, so you'll notice the intervals are the same for each table, but we do have 2 sets we're going to find. So let's start with this first table over here. All right, so we're going to go from x equals 1 to x equals 3. Now, you should know from our videos earlier how to find it in a table. I just need to look from 1 to 3. Let's get a little lighter colors with that. Let's try that. So from 1 to 3, that's my change in x there. It's going to be plus 2. And let's see my outputs that correspond there. Let's see, we go from 12 to 24. Let's see, that's a plus 12 there, okay? So, don't forget your average rate of change is going to be the change in y over the change in x. Well, I've already done the work. So my change in y was 12. And my change in x was 2. So 12 over 2, that gives me an average rate of change of 6. And that's for x equals 1 to x equals 3. So let's do it down now for x equals 2 to x equals 5. All right, so we're going to take these off. All right, so 2 to 5, we are going from 2 to 5. Let's see, that's plus 3. And then from 18 to 36, that's plus 18. All right, so my change in y over change in x. Remember, those triangles, you can just think of it as change in or the difference of. It's a Greek symbol, delta. All right, so the change in y is my output change. That was 18 over my change in x here was 3, and that's going to give me 6. All right, so what you may notice is the average rate of change was the same for both intervals, okay? That is what we call a constant rate of change, okay? And when you have a constant rate of change, that tells me that function is linear. So we know, due to the constant rate of change, that is a linear function. And if you want to investigate that a little further, or we did do that in the previous video, I believe. Or maybe it was a later video. It's in this lesson somewhere. All right, so let's move on to the second table, the one in the middle. All right, so we got this same ordeal, right? Get that out. So we're going from 1 to 3. So that's plus 2 again. And we're going from our outputs, it's now 14 to 30. 14 to 30. So we're going to do a change in y. 14 to 30, sorry. That's 16. Over your change in x, let's see, that's going to be, my change in y is over here, that's 16. My change in x is that 2. So I get 16 over 2, which gives me an average rate of change of 8. And then the second one, that was from x equals 1 to x equals 3. Let's do x equals 2 to x equals 5. Let's see what that gives us. Let's see, we're going to... All right, so 2 to 5. Let's see, that's plus 3 again. And then we have from 24 to 30, okay? So let's see, the change in y over our change in x, 24 to 30 was plus 6. Okay, so I have 6 over 3. Excuse me, sorry about that. Thinking too fast. And that gives me a rate of change of 2. So this is interesting because notice we don't have a constant rate of change. Notice our rate of change is 8 and then 2. So this is what we call a variable rate of change, meaning it varies. It's not the same. And we talked about this in the other video, but this specific type of function, you'll notice it goes up and then down, kind of looks, there's a way to look at this, but this is called a quadratic. And we'll talk more about that in the second quarter. All right, so our last table here, we still have the same intervals. So let's see. We're going to do change, let's go with, it doesn't matter. Here we go. So we're going from 1 to 3. That's another, oh, yes, that does matter. We can't do that color. There we go. 1 to 3, that's plus 2. And then over here at corresponding, I have 3 to 27. That's plus 24. So if I want to do my change in y over, I'm going to put, we are going from x equals 1 to x equals 3. So my change in y over change in x. See, my y is 24. My change in x is 2. So that's 24 over 2. That gives me 12. So over that interval, it was 12. And then we also need to do it from x equals 2 to x equals 5. And let's see. So 2 to 5 is plus 3. And corresponding with that, I have 9 to 243. Ooh, that's a big number. But that's going to be what? Plus 234. Okay, yeah. That adds up, right? So, let's... that 3 is really ugly. All right, so I'm going to have my change in y is at 234. Change in x is 3. So I'm going to have, and that's going to give me, let's see, 234 over 3. Give me a second. Let's see, 210 would be 70. 24 would be another 8, so 78, I believe. So once again, this is not a constant rate of change. This is because, notice, these are different rates here, different numbers. We talked about this in the other video, what type of function this is. This is a variable rate of change for this one, meaning it is not constant. And this is what we look at and we call an exponential function. And that'll be good for now. We've gone on long.